Today we are going to discuss about Norton's theorem. It states that any two terminals of a network can be replaced by an equivalent current source and an equivalent parallel resistance. This is nothing but an equivalent circuit of Norton's theorem. This is considered as a network circuit. It is nothing but a network. A load resistance RL has been connected across it. A load current IL is flowing through the RL. The final equivalent circuit after solving Norton's theorem, it is to be Norton's current, that is IN. It has to be connected in parallel with RN, that is Norton resistance, along with the parallel resistance, that is nothing but load resistance RL. The current flowing through the load resistance has been represented as IL. The constant current is equal to the current which would flow in a short circuit placed across the terminals. The parallel resistance is the resistance of the network when viewed from these open circuited terminals after all voltage and current sources have been removed and replaced by internal resistance. So first we have to find out the equivalent circuit parameters RL, Rn and In. For finding the current through RL, first remove the load resistor RL from the network and calculate the short circuit current ISC, or else the short circuit current can also be called as IN, which would flow in a short circuit placed across terminals A and B as shown in the figure. For finding parallel resistance Rn, replace the voltage source by a short circuit. So the voltage source has been replaced by a short circuit here in this circuit. And calculate resistance between phases A and B as shown in the figure. The Rn resistance, here we are considering R3, but these two has been connected in parallel, R1 parallel R2. So R1 into R2 divided by R1 plus R2 along with R3 has been connected. The resultant resistance of R1 R2 has been connected in series with R3. So now we are going to calculate the load current IL. IL is equal to IN into the opposite resistance Rn divided by the total resistance Rn plus RL. So Norton's resistance Rn is calculated as Rn is equal to VThevenin divided by IN, where VThevenin is the open circuit voltage across terminals A and B. If the network contains only dependent sources, then VThevenin is equal to 0 and IN is equal to 0. To find RThevenin in such network, a known voltage V or current I is applied across terminals A and B, and the current I or the voltage V is calculated respectively by Rn is equal to V divided by I. So Norton's equivalent network for such network has been shown in figure. So what are all the steps to be followed in Norton's theorem? The first step is to remove the load resistance RL and put a short circuit across the terminals. Find the short circuit current ISC or IN. Find the resistance RN as seen from points A and B. Replace the network by current source IN in parallel with resistance RN. Find current through RL by current division rule, that is IL is equal to IN into RN divided by RN plus RL. Thank you.